This is the imagery showing the orbits of Mars and of Earth going around the sun. But this takes about twice as long to get around the sun. So these are different time slots when we can do this. Here you see Mars is 248 million miles away. Here is a mere 36 million miles away. And that's what makes a difference when we are sending something to Mars and how much power we have to take in order to get it out there and get signals back. In order to get the imagery back, we have to get it back from the most powerful rockets that we have. This is the Titan rocket. This is the Centaur upper stage of the combination of DoD and NASA in order to get something aimed and properly processed till it lands on Mars in this little thing up here on top. The engineering model was shipped from Denver, where we put all these things together. And it went to JPL, and JPL then sent it to the California Science Center. This here, as we showed on the diagram, this is the meteorological boom. It tells us what the weather is. These are two eyes, so we can see in stereo where the thing was. And this is the arm that's here in yellow. So here we see the first images that came back from Mars. This is a little rocky terrain, but nothing that would have tilted the machine screwy. You can see the temperature here is minus 28 degrees Fahrenheit. This is pretty cold, and everything had to work at this cold environment, but before we let it go, we had to sterilize it at plus 300 degrees. We had to do that several times in order to make sure that we didn't have any earth bugs on it, and so we weren't analyzing life as it was in our domain versus where these rocks formed. The geologists wanted to make sure that they were looking at the right place for these rocks and that they were going to analyze them. The analysis machine was a trade-off that we made to do the experiment integration, and that was in a compartment inside this. But the geologists didn't believe that we were really aiming at the right place, so they sent out this boom and took a picture of it. And this here is what I call our selfie from 1976, so the geologists could tell whether they were analyzing the right rock or not. This pictorially is the analysis machine that we had invented for Viking 1. We had no idea what the other elements were. The scientist said, well, if you didn't find life, what did you find? So we had to figure out a way to do a chemistry test on Mars with this instrument here. And we did pretty well. This is an X-ray spectrometer. There's a trade-off of gamma rays, X-rays, but we wound up with this X-ray spectrometer, something like what your dentist does when he examines your teeth. Only instead of getting something back that you could see, this was the energy levels that were reflected off the different elements. And the elements are shown there at the bottom left. And so in all, we found about 30 elements in our travels. And each time the rover landed someplace, they extended this out so it could see what the elements were that it was recording. We'll jump ahead to 2020. There were some rovers that were sent out in between. These were small enough samplers, but vehicles that were able to move on their own wheels. And those were being commanded by people at JPL at the direction of the geology team. After 50 years, this Mars mission is a little different. You see in front there's the digger. This thing is going to dig underneath the soil and bring out slugs. There's a camera to see exactly where it's digging. And this will be on record for a return to Mars mission in 2031, to pick up the slugs that are 1 inch by maybe 5 inches deep. And that will do the job for the next mission. It'll even have its own scout with it, the little helicopter that will be looking around for more interesting places to land. And here's the rocket that we used. It was a little bit smaller, but still need the Centaur upper stage in order to do the final steering. But here it was for a 9-month trip to Mars, because Mars was closer at that time than at 1976. We launched that so the landing would be in conjunction with our friends in the European Union. And they took pictures of us, of the vehicle as it was descending. Here you can see the parachute that was opening up and the vehicle that was down at the bottom. Parachute was then used to lower the descent rocket. Here you can see the parachute descending and what they had to do to make sure they weren't bouncing off rocks, which would have broken up all of the equipment on board. They took pictures of it and matched it with the pictures that they had inside here. And if it was too far over, they would then autonomously move it. So this is autonomous movement of that spacecraft until they found a nice soft spot for it to land on. So that was right over here. This is the helicopter that we took out from the belly of the rover. There you can see the rover in the background. Here these were taking pictures to scout out to see which way was a good place for us to send the rover. The pictures then went back to the rover and then back to Jet Propulsion Lab. The scientists at Jet Propulsion Lab then decided which way to steer it so that it wouldn't get in trouble. The same kind of technique on board that was analyzing it that was used on the previous rovers. It was small, it was discreet. I was able to send back enough information so they could determine what the elements were in the area where this rover was stationed. Now here, as your kids can see, here's a young man in a spacesuit pointing out the various peculiarities of all the planets. And here it was in its pointing out the various characteristics. Here we see the Earth. Here we see Mars. We know very little about the rest of these. And this is up to the next generation to figure out. And we still haven't figured out how our star works. This is the sun.